Welcome back to the official channel of Amit Ranjan. Today, we're diving into an exciting and groundbreaking mission that has captured the attention of not just India, but the entire world. We're talking about the Aditya-L1 mission, India's ambitious endeavor to take a closer look at the Sun. So, why is India so keen on studying our nearest star up close? Let's explore the key reasons behind this captivating mission. Let us start with question, why there is need to study the Sun? The Sun is the nearest star and, therefore, can be studied in much more detail compared with other stars. The Sun is a very dynamic star that extends much beyond what we see. It shows several eruptive phenomena and releases immense amounts of energy. If such explosive solar phenomena are directed towards the Earth, it could cause various types of disturbances in the near-Earth space environment. Various spacecraft and communication systems are prone to such disturbances and, therefore, early warning of such events is important for taking corrective measures beforehand. The Sun provides a good natural lab to understand these phenomena that cannot be directly studied in the lab. The Aditya-L1 mission is fueled by the scientific curiosity to unravel the secrets of our Sun, its complex magnetic fields, solar storms, and the fundamental processes that govern its behavior. By studying the Sun's activity and dynamics, scientists hope to gain a deeper understanding of space weather, which can have a significant impact on Earth's technological systems, satellites, and even power grids. What are Lagrange points? There are 5 locations around a planet's orbit where the gravitational forces and the orbital motion of the spacecraft, Sun and the planet interact to create a stable location from which to make observations. These points are known as Lagrangian or L points, named after the 18th century Italian astronomer and mathematician Joseph Louis Lagrange. The Lagrange points are denoted as L1, L2, L3, L4 and L5. The distance of L1 from Earth, 1.5 million kilometers, is about 1% of the Earth-Sun distance, 151 million kilometers. India's space agency, ISRO, has been consistently pushing the boundaries of space exploration. With missions like Chandrayaan and Mangalyaan, they've shown their capabilities on both the lunar and Martian fronts. Now, with the Aditya-L1 mission, India aims to further solidify its position as a space superpower. By successfully sending a satellite to the Lagrange point L1, a stable point between the Earth and the Sun, India will demonstrate its prowess in mastering complex space maneuvers. The Aditya-L1 mission. Aditya-L1 is the first space-based observatory-class Indian solar mission. The spacecraft is headed for a halo orbit around the L1 point because a satellite placed therein has the major advantage of continuously viewing the Sun without any occultation or eclipse. This will provide a greater advantage of observing the solar activities continuously. Aditya-L1 will carry 7 payloads to observe the photosphere, chromosphere, and the outermost layers of the Sun, the corona, using electromagnetic and particle detectors. 4 payloads on board Aditya-L1 will directly view the Sun and the remaining 3 will carry out in situ studies of particles and fields at L1. The payloads are expected to provide information regarding the problems of coronal heating, coronal mass ejection, pre-flare and flare activities, and their characteristics, dynamics of space weather, study of the propagation of particles and fields in the interplanetary medium. Spacecraft's journey. Aditya-L1 will be placed in a low Earth orbit by ISRO's PSLV-C-57 rocket. Subsequently, the orbit will be made more elliptical and spacecraft will be launched towards L1 point by using on-board propulsion. As the spacecraft travels towards L1, it will exit Earth's gravitational sphere of influence, SOI. After SOI exit, cruise phase will start and craft will be injected into a large halo orbit around L1. It will take 4 months for the spacecraft to reach its destination. It seeks to study coronal heating and solar wind acceleration, initiation of coronal mass ejection, flares and near-Earth space weather, coupling and dynamics of the solar atmosphere at solar wind distribution and temperature anisotropy. 7 science payloads. Visible Emission Line Coronagraph, VELC, studies solar corona and dynamics of coronal mass ejections. Solar Ultraviolet Imaging Telescope, SOOT, images the solar photosphere and chromosphere in near ultraviolet and also measures the solar irradiance variations in near UV. Aditya Solar Wind Particle Experiment, ASPEX, and Plasma Analyzer Package for Aditya, PAPA, payloads study the solar wind and energetic icons, as well as their energy distribution. Solar Low Energy X-ray Spectrometer, SOLEXes, and the High Energy L1 Orbiting X-ray Spectrometer, HEL1OS, study the X-ray flares from the Sun over a wide X-ray energy range. Magnetometer is capable of measuring interplanetary magnetic fields at L1 point. Solar missions launched by other countries. One of the most inspiring aspects of the Aditya-L1 mission is its potential to spark the curiosity of the younger generation. As young minds witness India's achievements in space, they're more likely to develop an interest in science, technology, engineering, and mathematics, STEM, fields. This mission serves as a beacon of possibility, motivating aspiring scientists and engineers to dream big and work towards pushing the boundaries of human knowledge. Now let us go back to history, and see solar missions launched by other countries. 1960 to 1969. US's NASA launched 6 Pioneer missions, 5, 6A, 7B, 8C, 9D, Of 6 orbiter missions, 5 were successful, 1 failed. 1974-1997. Helios A, Germany US, 1974 to 1982. Helios B, Germany US, 1976 to 1985. ISEE-3, NASA, 1978 to 1982. Ulysses, ESA NASA, 1994-95. Wind, NASA, 19,942,020. SOHO, ISA NASA, 1996 extended till 2025. ACE, NASA, 1997 until 2024. All missions successful. 2000 to present. Ulysses, second pass, ISA NASA in 2001. Genesis, NASA, from 2001-04. Stereo A, NASA, launched in 2006 and active till September 2021. Stereo B, NASA, 2006 to 2018. Ulysses, third pass, NASA ISA, 2007-08, partial success. DSCOVR, NASA, February 2015, successful. Parker Solar Probe, launched by NASA, 2018 December 2025, en route. Solar Orbiter, ISA February 10, 2020, en route. CUSP, launched November 16, 2022 but no contact now. Conclusion. The Aditya-L1 mission is driven by a combination of scientific curiosity, the need to understand the Sun's influence on Earth, India's ambitions as a space superpower, collaborative international research, and the desire to inspire the youth. As the mission unfolds and the satellite ventures closer to the Sun than ever before, we eagerly await the invaluable insights and discoveries that it will bring us. Remember to subscribe for more exciting updates on space, science, and technology. Until next time, keep looking up.